Cinnamon Springs is a farming and retirement community with a population of 1,000. At an elevation of 5,000 feet, the town is a popular destination for hunters, skiers, and tourists who enjoy soaking in its world-famous hot springs. This water system provides treated ground and surface water to 550 service connections. The community of Cinnamon Springs has a rolling topography. For most of its history, the lone water source was a spring-fed pond 5 miles from town.
This is our surface water. Comes down the stream right up here, and we use this for more or less a settling pond now. This has always been a source for the town.
In the mid-1970s, the Department of Environmental Quality deemed that surface water turbidity was excessive during spring runoff and required treatment for the first time. To improve water quality, a dam, intake gallery, and slow sand filter were installed at the spring pond.
This used to be our old sand filter. We have a pipe that comes out and heads down to the new sand filter.
Since the spring is located in the mountains 500 feet above town, the system runs on gravity flow.
The water comes in those lines, in that line there with the holes, filters down through the sand at the bottom of this, and then goes into the clear well. That's our holding tank. And that other little building over there is our gas chlorination.
By 1984, area farmers noted an insufficient water supply during irrigation. They blamed city use for the shortage. The farmers filed and won a lawsuit, forcing the city to reduce usage during irrigation months. A citizen group demanded that a new test well be drilled within the city. When the test came back clear, the town constructed a water supply well and pump house. This well was a steady source for the community until 1995. That winter, the town suddenly lost access to its entire water supply. Just as the well pump failed, the surface water sand filter also became plugged. City workers had to plow through deep mountain snow to install an emergency bypass siphon over the dam. These measures restored the flow of surface water into the system. Because turbidity can severely inhibit chlorine treatment, a boil order was issued. Filtration is used to remove turbidity, but doesn't disinfect or effectively remove microorganisms. Slow sand filtration is just one way to filter out excess particulate from the water. Here are some other filtration methods used by systems to remove particulates. The following summer, a second well was drilled. Both wells are 200 feet deep, with submersible pumps located 150 feet below ground level. Since 1995, the system's 3 sources have been going strong, easily meeting demand.
This is our gas chlorination. Put these cylinders on here, and the weight shows us how much chlorine is left. And then it goes down the tube to a vacuum. So the only time chlorination is used is when there is water flowing through, causes a vacuum. And if there is a problem with the wells, with any of the pumps, this piece here will tell us what it is so we know how fast we have to respond. Telemetry is connected to our holding tank, tells the pumps when to kick on. If the sand filter isn't allowing enough water in per usage, then the pumps will kick on. And once it gets up to designated height in the tank, it sends message back here and it kicks off the pumps.
Homes in town experience 100 to 120 pounds of static water pressure. As a result, most people use pressure reducers. The main line is looped and tied into more than one source. If one part of town is shut off, water is still available from other parts of town. The system only increases water pressure at hydrants, though gravity flow pressure would be sufficient to meet fire demand during a power outage. Electrolysis has been a common problem in Cinnamon Springs. Electrolysis takes place when metals are in contact with ionic fluids. These ion-rich liquids conduct electricity, which speeds the corrosion process and over time destroys the in-ground pipes. Pipe manufacturers familiar with the geology of this area have discouraged the use of PVC because of the hot springs and geothermal heat. PVC can be used in most areas of town, However, some areas are so hot that the PVC would melt if used. In those areas, a special Canadian ductile iron has been used. This pipe is thicker and is supposed to be more resistant to electrolysis. However, operators have been disappointed that the pipe is not proven as resistant as had been expected. Water is monitored for coliforms monthly throughout the distribution system. Every day, the operator performs random sampling for chlorine residual around town. Since businesses are far easier to access than residences, samples are usually collected there. Until recently, customers would read their own meters and make payments on the honor system. However, some customers were not being very honest. Today, the system is in the process of installing radio read meters. This is a huge upgrade and will help the system collect monthly payments in a more consistent and fair manner. The efficiency of the Cinnamon Springs system is constantly improving. In the past, leaks would occur at least monthly. Replacing ductile iron with PVC in the areas where geothermal heat allows has reduced the frequency of leaks to every 2 years. Water rates have been increased over time to finance these repairs. All but 2 miles of main has been replaced. Under the current budget structure, these sections will easily be replaced within 2 years.